So after you've written the code, so giving you an outline of what the API is and how you're going to write these individual functions, and you can think of a lot of different things to do. There's lots of examples available. Again, you can go to the GitHub Pulsar library and get some example functions from some more realistic examples. But once you have this code in place, obviously you have to package it in such a way that it's can be deployed to Pulsar cluster and be executed inside the serverless framework of Pulsar functions itself. So let's get into how you package each one of these artifacts using the different programming languages, because it varies based on the programming language that you've written the function in, obviously, right? So the supported deployment formats for the Pulsar functions obviously vary based on the programming language, as I mentioned. So for Java, you can either use an Uber jar file or a nar file. Both of these have to contain all of these have to contain any third-party libraries you include in your code. There's no limitation on that inside as far as Pulsar functions are concerned. Just because we've shown simple blocks of code in the previous examples does not mean they have to be that. They are full functioning client libraries. You can include any sort of third-party libraries you want, things to do machine learning, things to do sentiment analysis, things to do database lookups, all these different libraries. And all those have to be included in these artifacts. Don't assume anything's going to be available at the function runtime library. For Python, you can use either a single Python file, a zip file, or if you're going to run in the Kubernetes runtime environment, pip install is also an option. You can have the Pulsar function library spin up the runtime of Python itself, and then basically interrogate the content itself to use pip install to do use the Python package library manager called pip to do an installation of these dependencies for you as well. That's another option. For Go-based functions, they have to be compiled and packaged as a .go file. That's really the only way to execute any sort of Go code, and Pulsar functions are not any different. They're the only compiled of the three languages supported. So if you want to do a jar file using for your Java-based Pulsar function, then the easiest way to do that is to use the Maven assembly plugin inside your POM file, and be sure to specify the class, the full name of the function as the main class of your generated jar file. So it's going to, at runtime, make sure that that's the class that gets instantiated and executed. If you don't do that or you skip that, then it won't work. If your Pulsar function uses third-party libraries, as I mentioned earlier, be sure to add this jar with dependencies description reference inside your Maven assembly plugin to guarantee that it's going to go out and grab all of these individual third-party dependencies and all their dependencies, do a full static analysis, pull in all the dependencies, bundle them in a single jar file, and all of that is highlighted here in this link here. You can go to this link to see additional details about that, but this is basically the steps required to make sure that those are the two key components. Make sure your main class is specified and you include all the dependencies, otherwise it will not work when you go to run these functions. Now, if you're using a Maven to build your Java function, and you want to package it as a nar file, then you just need to use this specific NiFi nar Maven plugin, and automatically handles the bundling of all the third-party jars for you automatically. So it does what all the Uber jarring does in a much simpler interface. It just makes it easier than the previous step. You don't have to specify the main class. You don't have to do the jar with dependencies. It bundles all that information for you as well. If you want to take this approach, here's a link to the documentation for greater details on that, but it makes it very easy to do. There's examples out on the internet that do both. That's really a matter of opinion or preference over which one you use. They're both going to work either way. To package Python functions into a one-time Python file, you need to do these three steps highlighted here. As we mentioned before, you have to write the class as we saw before. It inherits from a function, has a process method as well, has that defined there, has install the Python client, and then copy the Python file to the Python broker so you can deploy it from there. So you basically, again, this was one that has no dependencies. This is a simple self-contained Python library here. This is all you need to do. The details are defined here. This is more simple approach. If your Python library does not include any third-party dependencies, you can get by just deploying it as a Python file and nothing more. And that's simple to do. See the packaging details at this link. So this is just an example. Again, you import Pulsar function. This is just, again, you're defining to extend the function. You have an initialized class, and you have the definition. This is an example of something you can deploy as a Python file only because there are no other import statements here other than from Pulsar. And so when you at the Pulsar function runtime, this is going to be available. So that's fine. Everything else is self-contained. So this is just an example of what you can deploy as a Python file. To package a Python file with pip using the pip installer, then you have to do these particular steps instead. Here, again, this only applies if you're deploying it as a Kubernetes pod. We haven't talked about runtime environments yet, but this is one of the preferred options is Kubernetes pod. The other is a process. If you're running it as a process in a function worker, this is not an option because we won't do this stuff for you. But if you're running it as a Kubernetes pod, then we can do this additional installation, right? So the first thing you need to do is add the following in your function workers file. Here, you need to add this particular, set this to true. This is defaults to false. Basically, it's a flag that inside your function worker, which is a separate runtime environment that runs the actual Pulsar functions. It's a configuration set to false. It's saying, I will not let you change any user code. We set that to true. Then you use the generate sh script that is already provided in your in this particular directory of your Pulsar functions or inside your Pulsar distribution. So if you download the Pulsar library, you look at the Pulsar functions path, there's a script Python directory, there's a generate.sh script there that you can use. And that will generate a wheel file for you in the specified, whatever you specify the output directory to be. So here's an example of, again, if you're in that particular directory, you say generate sh, you give it the full path name to where your Python function is, and you specify where your output directory to be, and then you specify a version as well. Like I want this to be version 1.0.0 of my particular function, and it's going to generate a wheel file for you. Now, wheel file in Python basically is a manifest that contains not only your particular but your function, but all the different dependencies that it has, and then that wheel file itself is what's used internally to do the pip install for you automatically, right? So once you make that deployment, you have that particular wheel file, you do a deploy on that, and then the function worker, because it's configured to install the code dependencies, will access that wheel file and say, I need to install this, I need to import that, I need to import the other thing, and it will run through the process of doing a pip install for each of those dependencies and make sure they're available in your runtime environment for you automatically. Go is by far the easiest one. Again, you just write your Go function. As we showed in the API, you have your simple definition of handle request. You have the context object, you have your input type. You have your main method that calls that basically, and then you take that information along with any dependencies you have and use the Go build tool to build your Go file name here. It's going to produce an executable Go artifact. So you just say Go build whatever your function name is .go. It's going to return a configurable artifact file, and then you just can deploy that